Let me ask you something that might keep you up tonight. What if everything you've ever seen, touched, felt, or imagined, every person you've ever loved, every place you've ever been, every moment of your entire life, is just one tiny bubble floating inside an ocean of infinite realities? What if right now, at this exact second, there is another version of you watching this video, but making completely different choices, living a completely different life? That's not science fiction. That's not a movie plot. That is a real scientific theory that some of the greatest minds on Earth take seriously today, so buckle up. Because today, we are going to answer one of the biggest questions in all of science. How many universes actually exist? And I promise you, the answer is going to shake something deep inside you. Before we start counting universes, we need to agree on what a universe actually is. Most people think the universe is just everything. All the stars, all the galaxies, all the planets. Everything we can see through our most powerful telescopes. And yes, that's our universe, the observable universe. But here's the thing that blows people's minds the first time they hear it. The observable universe is not the whole universe. The observable universe is only the part we can see, the part whose light has had enough time to reach us since the Big Bang, about 13.8 billion years ago. It stretches roughly 93 billion light-years across in every direction. 93 billion light-years, let that sink in. 1 light-year alone is about 9.46 trillion kilometers. Now multiply that by 93 billion, we can't even write that number in a way that feels real to our brains. And yet, scientists believe the actual universe goes on far, far beyond what we can see, possibly infinite in size. But okay, that's just one universe, our universe. Big, beautiful, and almost incomprehensible. So, where do the other universes come in? That's where things get truly wild. The idea that more than one universe exists is called the multiverse. Now, I know what you might be thinking. Isn't that just something from Marvel movies? Yes, Marvel borrowed it, but scientists didn't borrow it from Marvel. Scientists had this idea first, and it didn't come from imagination. It came from math, from physics, from the deepest equations describing how reality actually works. In fact, the multiverse isn't just one theory. It's actually several different theories, each one saying that other universes exist, but for completely different reasons. Let's break them down one by one, and trust me, each one gets stranger than the last. This is the simplest and, in some ways, the most mind-melting multiverse of all. Here's the idea: if the universe is truly infinite in size, which many physicists believe it is, then space goes on forever in every direction, far beyond what we can observe. And if space goes on forever and matter is distributed throughout that space, then by pure probability and mathematics, everything that can happen will happen. Somewhere out there, if the universe is infinite, there is an identical patch of space with an identical arrangement of atoms, an identical planet, an identical solar system, an identical you sitting and watching this exact video. Not a copy, not a parallel dimension, just another place in the same universe that is so far away we will never reach it, never see it, never know it's there. This version of the multiverse doesn't require any exotic new physics, it just requires one thing: infinity. And if the universe is infinite, then copies of you don't just exist once, they exist infinitely many times. Somewhere in the infinite expanse of space, there is a version of you who became a doctor, a version who became an astronaut, a version who made every choice you never made. All of them equally real, all of them equally you. Just impossibly, unreachably far away. Now let's go deeper. This next idea comes directly from our best theory of the Big Bang, and it's called eternal inflation. Here's what we know. In the first tiny fraction of a second after the Big Bang, the universe went through a period of incredibly rapid expansion. I mean, incomprehensibly fast expansion. Space itself was stretching faster than the speed of light. This period is called cosmic inflation. Now, most scientists agree inflation happened. The evidence points strongly to it, but here's where it gets strange. Some of the leading theories of inflation suggest that inflation didn't just happen once, it's still happening right now. In a vast sea of expanding space, what scientists call the inflationary field, tiny quantum fluctuations constantly trigger new regions to pop out of the expansion and form their own isolated universes, like bubbles forming in boiling water. Our universe is one bubble, and there are an unimaginably large number of other bubbles, other universes, scattered throughout this infinite sea of expanding space. Each bubble universe pops into existence with its own Big Bang, its own laws of physics, its own constants of nature. Some universes might have stronger gravity. Others might have no atoms at all. Others might burn so fast they collapse in a fraction of a second before anything interesting can happen. We are in the lucky bubble. The bubble where the laws of physics happen to allow stars to form, planets to cool, chemistry to work, life to emerge, and humans to eventually sit around wondering about all the other bubbles. And according to this theory, the number of bubble universes out there is not just large. It is infinite. Okay, you thought the last two were wild. Hold on. This one comes from quantum mechanics, the physics of the very smallest things in existence, atoms, electrons, photons. And quantum mechanics is weird, famously, disturbingly weird. Here's the core strangeness. At the quantum level, particles don't have fixed, definite properties until you look at them. An electron doesn't have a definite location. It exists as a wave of probabilities, spread across multiple possible positions at once. When you observe it, when you measure it, it suddenly chooses one position and the wave collapses. But here's the question that has haunted physicists for a century: where do all the other possibilities go? When that electron chooses to appear in position A instead of position B, what happened to the reality where it appeared in position B? In 1957, a physicist named Hugh Everett proposed the most radical answer imaginable. Nothing happened to it, it still exists. Every time a quantum event occurs, every time the universe faces a fork in the road at the subatomic level, the universe doesn't choose one path. It takes all of them. Reality splits, branches, every possibility plays out in its own separate branch of reality, its own parallel universe. This is called the many worlds interpretation of quantum mechanics. And here's what makes this terrifying and beautiful at the same time: quantum events happen constantly. Trillions upon trillions of times every second, all across the universe. Which means reality is branching, splitting, unimaginably fast, constantly. There is a universe where you decided not to watch this video. A universe where you fell asleep 2 minutes ago. A universe where the Earth never formed. A universe where the dinosaurs never went extinct and they built cities and looked up at the stars just like we do. All real, all existing simultaneously, all perfectly legitimate branches of quantum reality. The number of universes in this model isn't just infinite, it's a kind of infinity that makes normal infinity look small. Now we enter the most philosophical, and some would say the most beautiful, idea of all. This one comes from cosmologist Max Tegmark, and it's called the mathematical universe hypothesis. Tegmark's idea is this: we know that the laws of physics can be written as mathematical equations. Everything in our universe, every force, every particle, every interaction follows mathematical rules with breathtaking precision. So here's Tegmark's question: what if mathematics isn't just describing reality? What if mathematics is reality? What if every mathematically consistent structure, every set of equations that doesn't contradict itself, actually exists somewhere as a physical universe? In this view, our universe is just one mathematical structure among an infinite number of possible mathematical structures. And all of those structures are equally real. This means there are universes with completely different numbers of dimensions. Universes governed by entirely different mathematical rules. Universes so alien that we wouldn't even have the words to describe what exists inside them. And every single one is as real as the one we're sitting in right now, okay? Deep breath. We've looked at 4 different scientific frameworks. The infinite universe, the bubble universes of eternal inflation, the branching universes of quantum mechanics, and the mathematical multiverse. So, what's the answer? How many universes are there? Here it is. Nobody knows, but the most scientifically supported answer is infinite. Not a really big number. Not more than we can count, infinite, and not just one kind of infinite. Possibly infinite in multiple different senses, each more staggering than the last. Now, to be completely honest with you, because this channel respects your intelligence, these theories are not proven. They are not confirmed fact. Scientists debate them fiercely. The frustrating challenge is that by definition, other universes may be impossible to observe directly. If they can't be tested, some scientists argue they aren't really science at all. But here's what is true. These ideas don't come from nowhere. They emerge naturally from our best, most tested, most successful equations in physics. Quantum mechanics is the most precisely tested theory in all of science. Inflation is supported by real cosmic data. The math keeps pointing in the same direction. The universe, or the multiverse, is under no obligation to be simple, or comfortable, or easy for human brains to picture. Reality is what the equations say it is, and the equations are suggesting something vast beyond all comprehension. Here's the thought I want to leave you with. For most of human history, we thought Earth was the center of everything. Then we discovered Earth was just one planet orbiting one star. Then we discovered our star is just one of 300 billion stars in the Milky Way. Then we discovered the Milky Way is just one of at least 2 trillion galaxies in the observable universe. Every time we thought we understood the scale of reality, we were wrong. Every time, reality turned out to be bigger, stranger, and more magnificent than we imagined. Maybe the multiverse is the next step in that long, humbling journey. Maybe our entire universe, with its 2 trillion galaxies, its hundreds of billions of stars per galaxy, its incomprehensible age of 13.8 billion years, is just one tiny thread in a tapestry of infinite realities. And somewhere in that tapestry, in some other bubble, some other branch, some other mathematical structure, another version of this story is being told. With different physics, different stars, different life. Or maybe no life at all, just empty, silent space with no one to wonder about it. We got lucky. We are here. We can ask the question. And maybe, just maybe, that's the most extraordinary thing in any universe. If this made your brain hurt in the best possible way, smash that like button, subscribe, and share this with someone whose mind you want to blow today. Next week, we're going deeper. What was there before the Big Bang? See you then.